Okay, great. So, welcome back to this fifth interactive live TA session on the NPTEL course Principles of Signals and Systems offered by Professor Aditya Jagannathan from IIT Kanpur. So, a little bit about myself before we begin. So, my name is Yashvanth, and I'm presently a PMR of Ph.D. student at the Department of EC at IISc Bangalore. And my broad research interests lie in signal processing and applications to wireless communication systems. And I currently focus on designing intelligent reflecting surfaces for 5G and beyond wireless communications. So if you have any queries or you would like to get in touch with me, you can contact me in the email that I show here. And you can also navigate to this web page that you see here in order to know more about me. Okay, so the topic that is the agenda for this week's lecture, this week's session will be on the fifth week, the topic covered in the fifth week, namely on Z transforms. Okay, so as usual, we will quickly go over a quick summary of what has been dealt in the week 5 of the course. Okay, so we started with the professor started with the Z transform. So basically, Z transforms are used to represent. It's 1 minute. So represent and analyze discrete time signals in systems. Okay. So you can think of Z transform as a counterpart of Laplace transform. So how we had Laplace transforms in order to analyze signals in systems in the continuous time domain, you have the counterpart of Laplace transform as the Z transform for discrete time signals in systems. Okay, so more or less all the concepts that we have seen in Laplace transform will carry forward for Z transform also, but with slight differences that we will see in the summary. Okay, so so the way that the Z transform of a discrete time signal is defined as something like this: x of z equal to summation n equal to minus infinity to plus infinity, x of n, z power minus n. So here the variable z, right? So for the LHS is a function of z, because on the right hand side you have summed over all n. So there's only left out is a z variable, which is that's why your left hand side is a function of z, and the z is basically a complex number. And you recall that you can represent any complex number z as the magnitude part times the phase part. So magnitude part is written as r, and e raised to j omega is the phase part, where omega is the phase of the complex number z. Okay, so similar to a Laplace domain transform, you can visualize your Z transform also to have its own domain called the Z domain, or the plane is called the Z plane, where you have on x-axis Z, a real part of the complex number Z, and on the y-axis imaginary part of Z. Although this is true, real and imaginary to form the two axes of the Z domain, the most popular way to describe your Z plane is through the polar domain. That is, the two-dimensional axis that I'm showing here are called the Cartesian system. But there's another system called polar domain, polar system, in order to represent a vector in plane, right? So in polar domain, you can represent the same complex number using r and omega. So for example, where r and omega are related to z as z equal to r times e raised to j omega. Okay, so this is one difference between Laplace transform and Z transform. In Laplace transform, we were only talking about the Cartesian domain, that is real part of S and imaginary part of S, where S is a Laplace variable. But in Z transform, we will again consider Z plane, but we will now talk about it in terms of R and omega instead of real part of Z and imaginary part of Z. Okay, so similar to Laplace transform, here also we have the notion of what is called the region of convergence. So region of convergence is defined as those range of values of z for which the z transform converges. Similar to the definition of the region of convergence for a Laplace transform. Okay, and as an example is as follows: suppose if your discrete time signal x of n is defined as a power n times u of n, right? So a is some constant, okay, and u of n is your unit step signal in the discrete domain. So you can substitute this x of n in this expression for z transform. Okay, this expression for z transform, and you can show that you will get x of z is equal to 1 by 1 minus a times z inverse. Okay, and again, similar to Laplace transform, in addition to the expression, you also have to specify the region of convergence. So here you can simplify this 1 by 1 minus a z inverse as z by z minus a, with a region of convergence z mod z greater than mod a. So what does it mean? So mod z is basic. So z is a complex number, and mod is a complex number is basically the amplitude, and mod a is some number. Okay, so if I say mod z is greater than mod a, that means it essentially focuses the ROC is something which I'm highlighting here. So if I draw a circle centered about the origin with radius a, okay, any complex number lying outside this circle will constitute the region of convergence. It's this mod of z greater than mod a essentially represents the locus of all points such that they all lie outside the unit circle centered at origin 0, 0 and with radius a. Okay, so that is basically this example. Now another example. So instead of this, if you consider a power n times
Sir,
u
excuse me,
of,
sir. Excuse me, sir.
yeah. Hmm.
Sir, how do we get that region of convergence, sir? That we have to
So
equate the z minus a to.
okay. So basically, again, see, see, again, you have z power minus n, right? So basically,
Yes, sir.
substitute this here, and see, this is an infinite series. You know that you can. This is see, it's an infinite series, and what you will end up is an infinite geometrical series. We know the expression for infinite geometrical series. That is standard. But if you recall, you will. So, for example, summation x power I equal to 1 to infinity is nothing but 1 by 1 minus x only if mod x is less than 1. Do you recall this formula?
I have doubt. How do we get at the region of convergence? Not the z by z minus a, sir. I could
Yeah,
understand
I
it.
understand. So see, oh, okay. So basically, that we are basically using this fact. Okay, I should tell this.
Okay, sir. I
So
got the geometrical progression formula. That's okay, sir. That
so then
how do we get to
basic
that region of convergence as z greater than modulus of z greater than modulus of a?
so basically okay, let me ask this way first, then let's go. So
Okay, sir.
it's nothing but 1 by 1 minus x if x is less than 1. This we know. There is a geometric formula. Okay, so now
Okay, sir.
your
Okay.
question essentially boils down to asking why should this happen? Okay, you're asking why should x be less than 1 in order for this to hold, correct?
Okay.
Hello?
I know that, sir. If and only if
Okay,
x is
okay,
less
then
than one,
then then,
then
then I
only.
understand. Okay, then let's
Uh,
derive it. Okay, a power n u of n, right? So summation a power n u of n. Okay, I don't have space here. Okay, it's okay. Let's go back to the tutorials part and let's do that here. No problem. So ROC for a power n u of n. Okay, so let's do this. So summation n equal to minus infinity to plus infinity x of z equal to x of n z power minus n, which is nothing but summation n equal to minus infinity to plus infinity a power n u of n into z of minus n. Okay, this is same as summation n equal to 0 to infinity because u of n is negative in the left hand side. Okay, sorry, a power n into z of minus n. This is same as summation n equal to 0 to infinity a into the whole power n. But recall that this both are there. They are basically complex. See, this z is a complex number. So if you go back to the geometric series of a complex number, this is same as 1 by 1 minus a z inverse if mod of a z inverse is less than 1. What is this? Mod z greater than mod a. That's what I wrote.
okay.
Okay.
Okay, sir. Right. Okay, right, sir. Right. Thank you.
Okay. So yeah, that is this is about it. Okay. Now, similarly, if you compute x of n equal to a power n times u of minus n minus 1, that is a left hand, that's the unit step signal on the left hand in the negative n domain, negative time axis. Okay. You can show that again your x of z will come out with the same z by z minus a, but your ROC will be now different. That is, mod z will be less than mod a. So recall, for your a power n into u of n, it was outside the circle with radius a. But now it is, the ROC is exactly, see, the Laplace, the Z transform is exactly the same, but the ROC is a complement of the first. That is your set of all points, which are lying inside the circle with radius a. Okay, so that is basically the difference. So what does this suggest? See, z by z minus a and z by z minus a both are common, both are same. So this suggests that different time domain signals can have same z transform expressions. Therefore, if you want to uniquely or fully characterize any signal, you should also mention the ROC of the transform. Okay, for example, here ROC is different. This is inside the circle. This is outer. This is outside the circle. Okay, similar to Laplace transform, if you recall. So, in fact, there also we had the same thing, a power n to u of n, and similarly, this is also left-hand signal. We saw that both gave rise to same Laplace transform, but their ROCs were exactly different. So, same thing is applicable to
Sir,
Z
small
transform
doubt,
also.
sir. Sir, in Laplace transform, only that some function multiplied with u of minus n, then we get the same type of Laplace transform, sir. But here, why it is shifted by minus 1, sir?
No, so basically the thing is, see, the reason is, see, if we shift by minus 1, what does it mean? Your u of n starts from only minus 1. So basically what I'm saying is as follows. See, yeah, okay, let me now erase this.
During lectures also, I got the same
Yeah,
doubt,
yeah,
sir.
I will
But
tell you, I will
in
tell
lectures,
you.
I could not.
So you see this, this is my u of n. Okay, it includes 0. Okay, but now if I write u of minus n, what happens is it will be like this. That also will include 0. So if you recall, what I want to do is I want to get rid of this z. I cannot, I mean, I don't want to have both, I want to have, say, basically this one. I don't want this to be same as this one. I mean, they should be both should not have any overlapping support. So, but here you see both are having overlapping support. That's why what I do, I remove 1 minus 1 and remove this contribution from 0. But that will not affect in case of continuous time signals. That is not a problem because it's a continuous time domain. So u of t at u of 0, it doesn't matter whether you include it in the in this part or this part. Essentially what I'm trying to say is, if you see there, it's an integral from 0 to infinity, or it's an integral from minus infinity to 0. Okay, both the values do, so these values do not matter whether you associate u of t into b. I mean, if you want your 0 value to be included in this integral or this integral, but in summation it matters. In u of n, it is n equal to 0 to infinity. In u of n minus 1 is, it's minus infinity to minus 1. It should not be to still 0.
Okay,
So,
sir. Okay, sir. Got it, sir. Got it. Thank you, sir.
yeah. Okay. So now let's look at some of the properties of Z transform. So this is again, yeah, this is again the picture that I took from the book Oppenheim, written by Oppenheim, chapter number 10. Okay. So if you look at the properties of Z transform, the first, so let's say you have original signal x of n with its Z transform x of z with ROC R. Now let's say I have two other signals x1 of n and x2 of n with its Z transforms x1 of z, x2 of z with ROCs R1, R2. Now we have the following properties. First is called the linear property. Okay, so what it says is, if you have the signal a times x1 of n plus b times x2 of n will have the Laplace z transform a times x1 of z plus b times x2 of z. And how will the ROC be? It will be at least the intersection of R1 and R2. Next is, So I'm discussing all these properties just to recall, but professor had derived all these properties in depth in the class. I remember that. Okay, so let's just quickly recall. The second property is time shifting, where if you do a shift in the time axis by n naught, x of n minus n naught, the corresponding z transform changes as you write e z raised to minus n naught times x of z. This is very similar to Laplace transform also. There you had e power minus st naught into x of s. Here you have z power minus n naught into the x of z. Okay, so it is very similar to Laplace transform. Scaling in z domain, that is, you multiply your x of n by z naught power n. Very similar to your Laplace transform. You scale in the s domain, right? Laplace domain. So similarly, you do scaling in the z domain. The corresponding z transform is given by this x of z by z naught. Okay. Now, similarly, time reversal means what? You x of n, instead of that, you consider signal x of minus n. Exactly flip the signal about your your y-axis. Then your Laplace transform will take and reciprocate. That is, minus n becomes 1 by z. 1 by z is z inverse. Okay, it becomes x of z inverse. Now, time expansion. Okay, this you can look at the Oppenheim book if you're interested. I don't think this was covered by professor, so I'm skipping for now. Now, conjugation. X conjugate of n. If you conjugate, then basically there's a conjugation in both z and x. That is, you replace x z by z conjugate, and then the whole expression x of z also you conjugate it. That is basically x conjugate of z conjugate. That is basically conjugation property. Convolution property. If you have two signals x1 of n and x2 of n, and you get a time domain signal that is a convolution of x1 and x2, then the corresponding Laplace transform will multiply. Okay, that is, if you have y1 of n equal to x1 convolution x2, then y1 of z equal to x1 multiplied x1 of z multiplied by x2 of z. First, the difference xn minus xn minus 1. So this is very similar to your differentiation in Laplace. Okay, dt dx of t by dt. Okay, in discrete time domain you don't have the notion of differentiation. That's why you have the notion of something called difference, not differentiation. So this is called a difference, and the corresponding your Laplace transform is 1 minus z inverse of x of z. Now next is called accumulation. So accumulation is the counterpart of accumulation in Laplace was integral. That is minus infinity to, let's say, t x of t, x of tau d tau. So that in the discrete time counterpart is summation. That is summation from minus k equal to minus infinity to n x of k. Its corresponding Laplace transform will be 1 by z inverse times x of z. Now differentiation in the z domain, n times x of n will have the corresponding differentiation Laplace transform minus z into dx of z by dz. Okay, so basically the properties of Laplace transform exactly mimic in the z transform also, but you have to take care of the fact that now we are doing in the discrete time domain. So for example, differentiation will become difference, integration will become accumulation, like that, and so on. Okay, so those kind of aspects you should take care. Now some common examples. Okay, so what are some typical common example of z transform pair? So this is also a picture that I took from Oppenheim book. So if you have delta of n, the z transform is equal to 1 and the ROC for entire z plane. If you have a unit step u of n, then the transform is 1 by 1 minus z inverse. Okay, and the ROC is mod z greater than 1. That is outside the unit circle. Outside the circle centered with radius 1, which means it's a unit circle. And similarly, minus u of minus n minus 1 will have a Laplace transform same as u of n, but the ROC will be exactly different. That is, now it will be inside the unit circle. Now, delta of n minus m is z power minus m. So again, ROC is the entire z plane except basically 0 if m is greater than 0, infinity if m is less than 0. So the way to check is just use delta of n minus m. Use this the definition of x of z is equal to summation x of n into z of minus n. Put the expression for the x of n here and then evaluate the summation and then find out the ROC, just like how I solved the example now before a little while back. Okay, so now next is alpha power n into u of n. its Laplace is 1 by 1 minus alpha z inverse with your ROC mod z greater than mod alpha. Similarly, you have 6 as a counterpart for 5 with just the ROC will be different. Similarly, now you have 7 and 8. You just multiply n on both sides for 5 and 6. You multiply n to equation item number 5 and 6, you get 7 and 8. So correspondingly, you will do a differentiation in the Laplace domain. In your z domain. Okay, and the ROC will remain the same. Now you have cos omega, sin omega, then some modulation r power n into cos omega, r power n, sin, all those things you can find you can do the computation. Okay, these are some Z transforms of some common signals. Now next is called the inverse Z transform. So okay, so suppose you have computed your Z transform from the time domain using the expression. Now if I want to go back to the time domain from the Z domain, the operation that you should be doing is called the inverse Z transform. So basically, what it says is given x of z, express x of z. Okay, so basically one way to do that is, okay, maybe there are two ways. So this partial fraction is the second method. The first method is called using power series expansion. Okay, so what I'm saying is, so you observe the definition of your z transform, not inverse z transform. You observe the definition of z transform. What it says, you take your x of n for every value of n, and for each value of x of n, multiply it by z power minus n, and then add all of them across n. That is how you define your z transform. That means, suppose if I express x of z equal to summation pk into z power minus k equal to minus infinity to plus infinity, then this pk should necessarily be x of k, that is time domain signal. Okay, this is a time domain signal. So basically what I'm saying is, if you are given x of z, some Laplace z transform, express your z transform as a power series in z. That is a z power 0, z power 1, z power 2, z power minus 1, z power minus 2, and so on. You express that as a power series, and the coefficient of z power minus n is basically your time domain signal x of n. And like that find every coefficient in the power series, and every coefficient will basically be the time domain sample value, and for all n. Okay, that is the first way to compute the inverse Z transform. That is first way to compute your time domain signal x of n given x of z. The second way is by partial fraction. So like similar to how we had in our inverse Laplace transform, you express your x of z as a rational function n of z by d of z. Okay, so numerator by denominator. So that can be written as something like this. Okay, so the zeros of the numerator polynomial is called the zeros of x of z, and the zeros of denominator polynomial are called as the poles of your z transform. So now, what are simple poles? Simple poles are those poles where every pole occurs only once. That is, there is no, all poles are distinct. Okay, then you can write your x of z divided by z. So there's a reason why we divide by z. I'll tell you later. Okay, so you express x of z divided by z as c naught by z plus c1 by poles of your z transform. Okay, and correspondingly you compute all your coefficients c naught, c1, and so on till cn. Okay, then basically what happens is you multiply both sides with z after you compute your c1, c2. Then what happens is this z will go off. It just c naught plus c1 z by z minus p1, so on to cn z by z minus pn. Right. So these are, we know the inverse transform of all these guys. Why? If you remember, alpha power n into u of n, which was the first example, had the z transform z by z minus a, z minus alpha. So you can immediately write down the inverse Laplace transform of each of these terms and then just add them up. And the first term is just a constant, so that will be delta of n times c naught. Okay, so that is basically with simple poles. Now, if you had poles with multiplicity, then what happens is, let's say the pole pi repeats r times. Then what happens is for the term, the partial fraction corresponding to the pole pi alone, you should repeat r times. Okay, I'm showing the expression only for pi. There are more terms before and after for other poles. But for pi alone, you should repeat r times. One is with a simple pole with a degree 1. The next is with power 2 and so on till power r. And then each of these coefficients, lambda 1, lambda 2, and so on till lambda r, will be evaluated using this. They are called the residues, right? They are basically evaluated using this lambda r minus k. This expression, very similar to our Laplace domain inverse transform. Now, from properties of ROC. So ROC does not contain any pole. Very similar to the, again, same as the Laplace transform property. For finite sequences, ROC is entire Z plane. For right-sided signal, ROC is basically something like of this form. Mod Z is greater than R max, where R max is the largest magnitude of the poles of X of Z. That is, it lies outside the circle with radius R max. For left-sided signal, the ROC is inside the circle with radius given by the smallest magnitude of poles of X of Z. For a two-sided signal, for example, something like this, it's a two-sided signal. The ROC is an annular region that is given by something like this. So mod Z between R1 and R2, where R1 and R2 are the poles of X of Z. So there's some poles of X of Z. Okay, so it's in between the two circles. So it's called the annular region. Okay, so if you recall, it's very similar. So in a Laplace transform, you had right-sided signal should have right half of plane, left-sided signal should have left half plane. So here, right-sided signal should have outside the circle, left-sided signal should have inside the circle. In your Laplace transform, two-sided, so two, if it was two-sided, you remember it should be a strip, right? In Z transform, it should be an annular region. Okay, so this is the analogy between Laplace transform and Z transform. Now going to system. System function of a Laplace of an LTI or LSI system. So if you have a system, a signal x of n as an input to a system h of with impulse response h of n, and you get the output y of n, then by the convolution property of z transform, your x of z multiplied by h of z is equal to y of z. Okay, if that is the case, then you can determine h of z to be just the ratio of y of z by x of z. This is called the system function or the transfer function of the given LTI or LSI system. Okay, so now using the Z transform, we will characterize the properties of system. First is the causality. So recall that if a system is causal, then its corresponding impulse response should be right-sided. Now, from the above properties, what does it mean? It means the ROC of your system function should be such that mod Z is greater than R max. Okay, that is the ROC of your system function should be outside some circle with the radius equal to the magnitude of largest pole. Now, stability. What does it mean for a system to be stable? That means its impulse response must be absolutely summable. Okay, that means professor had proved in class that it means your ROC of the system function should include your e power j omega. That is, the unit circle must be included in the ROC. Okay, so if the ROC has unit circle, that means your the system function, basic the system for which you're evaluating system function is going to be stable in nature. That is specifically BBO stable. Okay, so now how to determine the output of a system using Z transform? Okay, so you have x of n as the input, h of n impulse response, output is y of n. Then basically you can represent the input output of this system by this difference equation. Okay, so what is the recall that any LSI, that is linear shift invariant system, can be represented using linear constant coefficient difference equation, not differential, because here there is no continuum of time, it's only discrete time. Okay, that's why you have a difference equation. So this is the general input output relationship of a LS system can be represented like in this form of an equation. Now, if I want to, what you do, take Z transform on both sides and apply the properties of shifting properties of Z transform. then you can find that your system function will basically come out to be something like this. Okay. Now, basically, once you have a h of z, and then multiply with your input, whatever you get later, and then you find the output of your system, y of z. And then take the inverse z transform and find y of n. So that is basically the way to use Z transform to understand the output of any arbitrary system for a given input. Okay, so that basically it concludes a summary of week 5. So we will now jump into tutorials. Okay. Okay. The first question is, let x of n have the Z transform x of z, then what is wait, sorry, okay, maybe I'll ask like this. Let x of n equal to a power n into u of n. Okay, let x of n is equal to a power n into u of n. Find the z transform of n into x of n. Okay, that is n into a power n into u of n. What is the z transform of that signal? So this is a example of using properties of Z transforms. So what we know is, we know that n into x of n by properties of Z transform has Z transform minus Z into d by dz of x of z. So if I have to go back to the table, I'm basically using this property, the last property. N into x of n will have Laplace transform Z transform minus Z into dx of z by dz. Okay. Therefore, what is first x of z? X of z is nothing but a power n into summation n equal to minus infinity to plus infinity a power n u of n into z power minus n. Okay, that is nothing but summation n equal to 0 to infinity a power n z of minus n, which is what we calculated above. It came out to be z by z minus a. Of course, ROC is mod z greater than mod a. Okay, that is x of z. Therefore, n into x of n, that is basically n into a power n into u of n, will have the z transform minus z into d by z dz of z by z minus a, which is nothing but, of course, you need to use the property, so we'll do it. This is nothing same as minus z into z minus a into d by dz of 1 into 1 minus z into d by dz of z minus a, that is also 1 divided by z minus a the whole square. This is same as minus z into z minus a minus z by z minus a the whole square, which is minus plus az by z minus a the whole square. Okay, that's all. ROC is same. Okay, so that was the first problem. So just you have to use the properties of Z transform. Now, next question. Show that if x of n is a real signal, that is, for every time the signal takes only real values, okay, then the zeros of x of z occur in conjugate pairs? This is the second question. So what do you mean by zeros of a z transform x of z? So zeros. So set of z for which x of z equal to 0 forms basically it's called zeros of x of z. Okay, so now what this question says is, suppose if x is a zero of x of z. Okay, to show, what should we show? If x of z equal to 0, then you should show that x of z conjugate is also equal to 0. That means if I found for a real signal x of n, if I found z to be a 0 of x of z, that is x of z equals 0, then the z conjugate will also be the 0 of the polynomial x of z. That is, x of z conjugate is also equal to 0. That is the meaning of saying that zeros of x of z occur in conjugate pairs. They are conjugate, right? So basically, if x is a z is a 0, the z conjugate is also a 0. That is what we need to prove. Okay. So what we do is we just go back. So this is very, very simple. Just write on the definition of a z transform. X of z equal to summation n equal to minus infinity to plus infinity x of n into z of minus n. That is the definition. Correct? Now, since x of n is real. Okay, so now, okay, maybe I'll do something. Let's call this equation 1. Take conjugation on both sides to equation 1. Okay, that means what? What does it mean? Um, okay, so basically, okay, maybe I will read what it becomes x conjugate of z, right, equal to summation n equal to minus infinity to plus infinity x conjugate of n into z conjugate of minus n, because that is a complex number, so it will also have z conjugate power minus n. But x is a real number, right? X is a sorry, x of n is a real signal. So what does it mean? So you can replace, so this x is a real signal. Therefore, your x conjugate of my n will become just x of n into z conjugate of minus n. Correct? So what does it mean? It implies this is nothing but x of z conjugate. Okay, correct. This is but x of z conjugate. What does it mean? Therefore, if z naught is 0 of x of z, implies z naught is 0 of x conjugate of z, because we just took conjugation of 0 will not become 0, will become 0 only. So x z naught is also a 0 of x conjugate of z, but we proved that x conjugate of z is same as x of z conjugate, implies z naught is 0 of x of z star, or z naught star is 0 of x of z. So we started with saying z naught is a 0 of x of z and proved that z naught conjugate is also 0 of x of z.
Sir,
Okay.
excuse
So,
me, sir. Please explain once again, sir. This
so see,
conjugation.
so till here is it clear? Till here. So which part do you have doubt? Is this clear? Can you unmute and talk?
Okay, sir. That up to that point is okay, sir.
Okay. So now, so basically, what did I show? So let's go over it. So I'm saying z naught is 0 of x of z. That means what? X of z naught is equal to 0. Okay. Now, what I know is I take conjugate on both sides. Okay. So it means x conjugate of z naught is also equal to 0. Do you agree with this?
Yes, sir. As it is 0, conjugate is
Correct.
also
0
0.
conjugate will be 0 only. But
Yes, yes,
now,
sir.
what did I show here? I showed that for any z, x conjugate of z is same as x of z conjugate as long as x of n is real. I showed that here. It is okay?
Okay, sir.
That means, what does it mean? This means that this is same as saying x of z naught conjugate equal to 0. So is this okay?
Okay,
That
sir.
means
Okay.
z naught conjugate is 0 of x of z. That's the argument that I have.
Okay, sir.
So
Okay, sir.
basically the result is that for any real signal, your 0 will occur in conjugate pairs. Okay. So we'll now move to the next question. Okay. Find the. Okay, maybe I will first write. Let x of n have the Laplace z transform x of z. Okay. Then find the z transform of x of n naught minus n for some fixed integer n naught. Okay. So basically, you see what I've done? I have kind of basically made minus n. N became minus n. On top, we basically shifted by an amount equal to n naught. Okay. This you can think about it as x of minus of n minus n naught. Okay. So basically, you need to find the Laplace transform of this x of n naught minus n in terms of x of z, which is a Laplace transform. Sorry, z transform of x of n. Okay. Let's see the solution. Again, it's just by definition. Okay, just by definition. So x of z is basically equal to n equal to minus infinity to plus infinity, x of n, z of minus n. Okay. So now basically what I need to do is n equal to minus infinity plus infinity, my x of n naught minus n times z power minus n. You can write this as m equal to minus infinity to plus infinity x of m into x of minus of n naught minus n. How did I get this? Just basically put m is equal to n naught minus n. Okay. Then basically n will become n naught minus n. Then that is basically what I'm having here. The limits will still be minus infinity plus infinity. Okay. Because if n ranges from minus infinity to plus infinity, then m equal to n naught minus n will range again from minus infinity to plus infinity only. Okay. So that is this case. Now this is with respect to n naught is a constant, so pull that out. So this is nothing but z power minus n naught into summation m equal to minus infinity to plus infinity x of m into z power m into z power m. But there is now same as z power minus n naught into summation m equal to minus infinity plus infinity x of m, but it is z power m, right? So I can write something like this: z power minus 1, the whole power minus m. So that minus 1 into minus m will become just m. Okay. Now you see what is this? So if I call z inverse z not z inverse as some other z prime, that means it's nothing but z power minus n naught into x of z prime. Correct? The Laplace transfer, the z transform evaluated at the complex number z prime. Okay, but z prime is same as z inverse. So this is nothing but z power minus n naught into x of z inverse. Okay, therefore, if x of n has a z transform x of z, it implies x of n naught minus n will have a z transform z power minus n naught into x of z inverse. Okay, I just showed you, kind of have proved the property itself, but you could have directly proved it instead of showing. For example, you can show that your x of n naught minus n is same as x of minus of n minus n naught. That means what are you doing? You're basically first applying basically a negative axis. So basically, if you have x of minus n naught, that will give rise to x z inverse. And then on top of that, you are adding another delay, right? X minus n naught. So you should have a corresponding delay, z power minus n naught into x of z inverse, okay, which is the same as what we did above. Okay, so you can approach the same problem in two approaches. One, just going by definition, just doing some rearrangement of variables. The other is just use the two properties. So basically, what did I use? I use these two. Going back to the table. So you see here, I use this property. First, I use x of n is same as will give x of z inverse. And then I use a property, this time shifting will give rise to z power n naught in the Z. I use these two properties. Okay, so that is basically the third question. Now, fourth question is as follows. Find the ROC of x of z if x of n equal to 5 power minus n plus 1 times u of n plus 1 minus 4 power n into u of minus n minus 1. Okay, so this is basically the given signal x of n. What is the question is you need to find the ROC of the Z transform of this signal. Okay. Solution. So basically, what did we if you remember the example that we saw, your 5 power minus n plus 1. Okay, we'll split in two terms. It has two terms. One is this first term, 5 power minus n plus 1 into u n plus 1. Second signal is 4 power n into u of minus n minus 1. And the ROC is the intersection of both of them. So that is what we saw in the property of ROC. Okay, so let's consider the first signal, 5 power n plus 1 into u of n plus 1. Okay, now you can find I'm not interested in the exact expression for Z transform. All we are interested is what? The ROC of this ROC of the Z transform. Now, so see, so basically what will happen is your ROC will be something like mod Z greater than here it is. Okay, maybe let's do this little more property. So you can write this as 5 by 5 power n. That is same as 5 into 1 by 5 power n into u of n plus 1. Okay. Now the thing is you can show that basically it is some constant times alpha power n times u of n plus 1 by shifted. So basically you will have a Z transform and you will also have a shifting property because n plus 1. But what about ROC? ROC will not change by shifting. Therefore, ROC is of the form your mod Z greater than 1 by 5. Do you agree? Do you agree? Because I'm not exactly writing out the Z transform. I'm only interested in knowing the ROC of the Z transform. Do you agree that your ROC will be of mod Z greater than 1 by 5? Because these are the form a power n into u of n plus 1. That plus 1 will only give us a shift in your Z transform expression, but it will not change the ROC. So is this okay? Recall that if your a power n into u of n will have a ROC mod greater than mod e. That's what I wrote here. Mod greater than 1 by 5. Is this okay?
Yes, sir.
Yeah, good. So that is the first part. Now the second part is 4 power n into u of minus n minus 1. Okay. So now can you tell me how will the ROC be? See, this is u of minus n minus 1. It's a left-handed signal. Okay, left-sided signal. Means its ROC should be something inside some circle. That means your mod Z should be less than some value. Here, what is that value? A power n. Exact. Less than. Correct. Is less than 4. Correct. So mod z is less than 4, and in the upper part you're getting mod z greater than 1 by 5. But if you add both of them, at least it should be intersection. Right? It should be intersection of both of them or subtract. Therefore, ROC of your entire signal x of z is nothing but mod z between 1 by 5 and 4. Is this clear?
Yes, sir. Clear, sir. Clear.
Yeah, thanks. Okay, so next let's solve this question. Find the z transform x of z and sketch the pole zero plot with the ROC for the following signals. Okay, number 1, x of n equal to half power n into u of n plus 1 by 3 power n into u of n. Number 2, x of n equal to 1 by 3 power n into u of n, but now 1 by 2 power n into u of minus n minus 1. Okay, that is now both here. Okay, let me first finish the question. The third is x of n equal to half power n into u of n plus 1 by 3 power n into u of minus n minus 1. So the first question is both are right-handed signals, so the result is also right-sided. Second question is first term is right-sided, but the second term is left-sided. When you add both left and right, it is a two-sided signal. Third question is also two-sided signal, except that the right-sided signal is now dominated by 1 by 2 instead of 1 by 3. And the left-sided component is now dominated by 1 by 3 instead of 1 by 2. That is the only difference. So now the question is, okay, these are the three signals. For each of these signals, find x of z. From the x of z, find the pole zeros and plot these pole zeros on the plot, on the z domain plot. Along with that, mark the region of convergences for all these three signals. Okay, let's solve it. Okay, let's take the first signal, namely first signal is x of n equal to half power n into u of n plus 1 by 3 power n into u of n. Okay, so now let's do one by one. So 1 by 2 power n into u of n. What is the z transform? Z by z minus half. What is the ROC? Mod z greater than half. Okay, similarly, 1 by 3 power n has a z transform z by z minus 1 by 3, and the ROC is mod z greater than 1 by 3. Okay, so basically, okay, so this is basically your z transforms. Now we need to find the pole zero plot. Okay, so for pole zero plot, what should you do? You should first find the zeros and poles. That means first to find out the x of z. Therefore, your x of z is nothing but z minus half plus z minus 1 by 3. If you simplify this, you can show that this can be written as 2 into z by z minus 5 by 12 by z minus half into z minus 1 by 3. Okay. Now, what should be the common ROC? Tell me. So basically, for the first signal, the ROC is something like this. This is half and outside. For second signal, it is 1 by 3 and then outside. Which is smaller? Is it 1 by 3 or 1 by 2? Sorry, you should talk about bigger,
One.
right? Because now you have to intersect both the ROCs. So one says it is bigger than 1 by 3. The other ROC is bigger than 1 by 2. The intersection is bigger than 1 by 2. Do you agree?
1/2.
Correct. Correct.
Yes.
Therefore, your Z greater than 1 by 2, this region intersection Z greater than 1 by 3 is nothing but Z greater than half. Okay, Z greater than half. Therefore, your the final Z transform X of Z will have the ROC is mod Z greater than 1 by 2. Okay, now it's easy. What are the
Sir,
poles?
small doubt, sir.
Hmm.
Sir, how it will be Z greater than half, sir? Z 1/3 is small value, so it covers everything.
Yeah. So basically, okay, let's look at it. So basically, okay, let's draw it properly now. Maybe with different colors. This is, let's say, Z equal to 1 by 3. And let's say this is Z equal to half. Okay. Z equal to half and Z equal to 1 by 3. Is this okay?
Okay, sir.
Now,
Okay.
my first signal the ROC is greater than half. That means it is this value, all outside this circle. The second signal ROC is greater than 1 by 3. Now, if for example, if I take any number here, at this point, my pink the ROC for the pink signal does not cover, right? That means at that green point, my first signal will not converge. Do you
Okay, sir.
agree?
Okay.
That
Yes, sir.
means,
Yes.
but if you take outside Z equal to half, then both the signals will converge. Because anyways, that is greater than Z by 1 by 3 also.
Okay, sir. Okay. Okay.
That's why when you do intersection, that's what I meant by here. Basically, you have the region greater than half, intersection region greater than 1 by 3 is a region greater than half. That's why the total, the ROC for the entire composite Z transform is mod Z greater than half. Let me maybe write here. First signals is X of Z does not converge at this point. Okay. So now what we need to do? Now tell me what are the zeros of this polynomial? Zeros of X of Z. Yes.
5/12, sir.
Only that?
And 0.
Correct. And 0. Poles, half and 1 by 3. So now we are asked to plot it, right? So let's now plot. So you have the Z domain, Z axis. This is basically imaginary part of Z. This is basically real part of Z. And basically my ROC is mod greater than half. So basically this is my ROC. So you put Z equal to half here. And this is my ROC. And I need to also do the pole zero plot. That means I need to indicate where the poles and zeros are. Okay, so here zeros are 5 by 12 and 0. So for 0, generally we make a circle. This is at 0 and 5 by 12 is somewhere here. I don't know. Somewhere here, 5 by 12. Somewhere just less than half. Because 6 by 12 is half. So 5 by 12 is just less than half. But your poles are 1 by 2 and 1 by 3. So for poles, what we do is we make a circle and then put a cross to say that it is a pole. It's a cross. So it is, so maybe this is not, oops. Maybe here. Cross, this is 1 by 3 and 1 by 2. Okay. This is a pole zero plot along with the ROC. Now, similarly, I will do the second question. What is the second question? Half 1 by 3 power n into u of n, x of n equal to 1 by 3 power n into u of n plus half power n into u of n minus n minus 1. Half power n into u of minus n minus 1. Okay, so Let's again do the same procedure. Let's say call this as x1 of n and call this as x2 of n. So basically x1 of n is equal to 1 by 3 power n into u of n. We'll have the z transform z by z minus 1 by 3 with mod z greater than 1 by 3. Now x2 of n equal to half power n into u of minus n minus 1 will have a z transform minus z by z minus half with mod z less than half. Why less than half? Because the left sided signal, see minus n minus 1. Here it is just n. Okay, this minus because you should have a minus up before. Okay, so that is basically this thing. That means, what does it mean? That means therefore your x of z equal to x1 of z plus x2 of z equal to z by z minus 1 by 3 minus z by z minus half, which is, you can show that this is nothing but minus 1 by 6 times z by z minus 1 by 3 into z minus 1 by 2 into z minus 1 by 3. Now what is your ROC? Mod z greater than 3 intersection mod z less than half. Let's now see what is the intersection. Okay, so mod z greater than 1 by 3. So for x1 of z, I'm just drawing the ROC. Mod z greater than 1 by 3. This is 1 by 3 greater than, this is ROC. And for x2 of z, what is the ROC? Mod z less than half, which means it's inside the unit circle, now inside the circle with radius half. But 1 by 3 is less than 1 by 2. That means if I intersect them, what is ROC? Somewhere, something like this. Okay, so sorry for the figure. This is 1 by 3, this is 1 by 2, and this is basically your annular region. Is it clear?
Yes, sir. Yes, sir.
Yeah. So basically, the ROC is that mod z between 1 by 3 and 1 by 2. On the same figure, I can mark the zeros. What are the zeros? Zeros. It's just 0 because only you have z. What are the poles? Half comma 1 by 3. Just mark them here. So your 0 is here, 0. And 1 by 3 comma 1 by 2. So these are your poles. Okay. Are there any doubts? Okay. So now let's solve the last part of the question. That is it's basically now 1 by 2 power into u of n plus 1 by 3 power n into u of n minus 1 minus 1. 1 by x of n equal to 1 by 2 power n into u of n plus 1 by 3 power n into u of minus n minus 1. Okay, now can you guess what is the answer? Same thing, you can do same thing. X of x1 of n is nothing but 1 by 2 power n into u of n, whose Laplace transform will be z by z minus half with mod z greater than half. Similarly, x2 of n also same. 1 by 3 power n into u of minus n, u of minus n minus 1 will have a z transform z by minus z by, sorry, minus z by z minus 1 by 3 with mod z less than 1 by 3. Now can you guess what is the answer? Now if I basically, what is the common ROC?
No common ROC. One will be exterior and another one will be interior.
Exactly. So if there is no ROC, what is the Z transform X of Z?
It will not exist.
Sorry?
It will not exist.
Correct, correct.
It
So
does not
this
exist.
correct. This signal will not have any Z transform. Means it because I cannot find even one point where x of z converges. Means it doesn't have it. X of z does not exist. Okay. So let's maybe common intersection. Let's just maybe I'll draw it for those of you who didn't understand. So for x1 of z, it is outside half. Okay. Your x2 of z, it's inside 1 by 3. So if you intersect them, what will you have? You will have something like this: half and 1 by 3. Okay, these are for x1 of z and this is for x2 of z. X1 of z. There is really no common ROC between x1 of z and x2 of z because one is exterior to half, other is interior to 1 by 3. Therefore, no common ROC implies at no point on the z plane x of z, which is equal to x1 of z plus x2 of z, converges. Therefore, x of n does not have x of z. Is it clear?
Yes, sir. Clear, sir.
Yeah. Okay. So we will now do one question and then go for a break. Okay, a very similar question. That's why I wanted to finish it off. This is question number 6. Okay. The question is, let x of n equal to a power mod n. Okay. Where I know that I am given that a is some number which is greater than 0, a real number. Question is, sketch x of n for a less than 1 and a greater than 1. Second question is, find x of z and sketch the pole 0 plot and ROC for a less than 1 and a greater than 1. Okay, it's very similar to the previous question, but here you need to sketch your x of n also. Okay, so it's a power mod n. So what is it? What does it mean to be a power mod n? Means whenever n is positive, mod n will take equal to n. Whenever n is negative, mod n will become equal to minus n. Okay, let's first start with that observation solution. Recall, mod n will be equal to n if n is greater than or equal to 0, minus n if n is less than 0. Okay, so this is the first observation. So basically, because of this, we can write, therefore, x of n equal to a power n if n greater than or equal to 0, a power minus n if n less than 0. Okay, now we'll sketch x of n for a less than 1. Okay, first case, a less than 1. What is it? What do you mean by a less than 1? As n increases, let's say you concentrate on your n greater than 0 part. As n increases, and if a is less than 1, a power n, will it decrease or increase?
Decreases,
If n,
sir.
sorry, can you repeat?
Decreases, sir. Decrease. Value decreases.
Correct, exactly. So basically, you can show that your plot will be something like this. And at n equal to 0, what is the value? At n equal to 0?
1, sir. 1.
Correct, 1. So you get 1, then it will decrease as n increases. and it will go on. Similarly, on this also it will be similar, because at n equal to -1, what is a power minus n? It's same as a power minus of -1 is a itself. That means it's same as n equal to 1. Similarly, at n equal to -2, a power -2 is nothing but a square, which is same as x of 2. Right? So basically, this signal is symmetric about your y-axis. Okay. This is for a less than 1. Now, similarly, for a greater than 1, how will it be? Yes. Will the signal increase or decrease as with n? It will increase because a is greater than 1. Okay. So it will be something at 1, it will be at a. Okay, is this clear? This will, okay, I hope it's clear. Yeah.
Yes,
Okay.
sir.
So yeah, thanks. So this is just sketching of signals a less than 1 and a greater than 1. Now let's solve the second part of the question, which is basically to find the Z transform and sketch the pole zero plot along with the ROC for both values of A. This was our first part, B part. Okay, so now, okay, so basically what did we say? We say that x of n is nothing but a power n if n is greater than or equal to 0, or n if a power minus n if n is less than 0. That is from n equal to -1, -2, -3, and so on, it will have a power minus n. Therefore, I can compactly write this as a power n into u of n plus a power minus n into u of minus n minus 1. Is this okay?
Please explain, sir, once again.
So you see, basically, what will happen? What will happen to a power n into u of n? That means whenever n is greater than 0, you will have a power n. This term will not be. This term will be 0, because for n equal greater than 0, this will be u of let's say -2 -1, or u of -3 -1 will be u of a negative number. So the second term will be 0. So x of n will be equal to just a power n whenever n is greater than or equal to 0. Is this okay? So basically,
Okay, sir. Okay.
yeah, basically for n less than 0, this term will be 0. This will be equal to 1. So you just have a power n. So that means whenever n is greater than 0, x of n will be equal to a power n. Now, whenever n is a negative number, let's say -1 or -2 or -3 and so on, this first term will be 0, because u of any negative number is 0. But the second term will be this u of -n minus 1 will be equal to 1. So x of n will be equal to a power minus n if n is less than 0. And that is basically the second condition. So basically what I'm saying is you can capture both this condition by just single signal. Something like this.
Okay, sir. Okay. Clear.
Yeah. Okay. So then basically this is basic. So I need to find x of z for this expression. So what is x of z? Again, call this as x1 of n and call this as x2 of n. So x1 of n has the z transform as z by z minus a. And what is the ROC? Mod z greater than mod a, or just a, because a is a real number. X2 of n has a z transform z by z minus 1 by a, because z power a power minus n, I can write it as 1 by a power n. That's why it's just z minus 1 by a. Okay, and but the ROC will now be interior to circle with your radius a, because I have u of minus n minus 1. Okay, now let's consider this is the Laplace transform for both x1 x2. Now let's consider the case a less than 1. If a is less than 1, Sorry, this is 1 by A, right? It's not A. It's mod z is less than 1 by A. Okay. Now, if A is less than 1, what is the ROC? So your mod z greater than A will be something like this. So let's first draw the unit circle. Okay. Sorry, my diagrams are a little weird. So just a minute. Okay. Let's draw the unit circle. This is mod z equal to 1. Let's say I pick a number A is less than 1, right? So that means your A is somewhere here. This is basically equal to 1. So A is less than 1. So this is my circle. And it says mod that's greater than A. That means this will be the ROC for x1 of z. Similarly, for x2 of z, mod z should be less than 1 by A. When A is less than 1, 1 by A will be more than 1. Okay. So basically, let's say this is your A. So your 1 by A will be somewhere here, and draw a circle with that also. Okay. And it will be interior to the circle. So all of them will be ROC. Okay. Therefore, if you common, what is a common ROC? It will be
greater than A, less than 1 by.
correct. This is A, 1 by A, the annular region between A and 1 by A. That is the common ROC. Okay. So that means this is the common ROC. And what is the Z transform expression? X1 of Z plus X2 of Z. Basically, whatever we derived above. Z by Z minus A plus Z by Z minus 1 by A. Okay. You can show that will come out to be Z by Z minus A plus, okay, there's a minus Z by Z minus 1 by A, which is equal to A square minus 1 by A into Z by Z minus A into Z minus 1 by A. And what is the common ROC? Mod Z between A and 1 by A. Okay, so what are the poles? What are the zeros? First, tell me what are the zeros? Just 0. And poles will be A and 1 by A. So just mark them on this diagram. So this is a 0. And these are the poles. Is it clear?
Yes, sir.
Yeah. Okay. So now the next question is this for A less than 1. For A greater than 1, can anyone guess the answer for A greater than 1? So for your x1 of z, your ROC is mod z greater than A. Okay. But now A is greater than 1. The 1 is here, A is here, and this is a circle, and this is greater than A. And similarly for x2 of z, it's mod z less than 1 by A. When A is greater than 1, 1 by A will be less than 1. So you have something like the here, 1 by A. And that will be mod z less than 1 by A. So it's interior to the circle. Now tell me what is the common intersection region?
No common intersection.
No
No
common
common.
intersection. Correct. Correct. No common intersection. Therefore, x of z does not exist. You should not write x of z is equal to this expression. You should not write this is not the expression. This is correct as long as you have some valid finite ROC. When you don't have any ROC, that means your x of z doesn't converge to this value at all. So there is no x of z. Okay. So when A is greater than 1, there is no ROC or no Z transform. When A is less than 1, yeah, this is Z transform with the ROC between A and 1 minus A, 1 by A. Okay, so we have completed what I think 6 questions. We'll take few more questions, but before that, let's go for a short break. Okay, so we'll maybe meet at again 10-minute break will take around 7:29. We will again begin. Okay, am I audible?
Yes, sir.
Yeah. Okay, let's resume then. Okay, so maybe give a minute more. Maybe let my pencil get charged. Okay, so let's resume. Okay, so this is question number 7. Okay, so the question is as follows. Consider a discrete time LTI system with impulse response h of n equal to same alpha power n into u of n. Okay, so the question is examine the conditions under which number 1 the system is causal and number 2 the system is Bibo stable using Z transforms. Okay, so basically all we need to do is, if you remember, for stability your Z transform should be an exterior part of your circle, some circle with the radius equal to the maximum pole, and for Bibo stability your unit circle should be included in the ROC. This is what we need to check, as simple as that. Okay, so solution. Okay, so basically the impulse response is very simple. H of n equal to alpha power n into z of u of n, and we know that it's a z transform is nothing but z by z minus a, sorry, z minus alpha, where mod z is greater than mod alpha. Okay, therefore ROC is mod z greater than mod alpha, implies ROC is exterior part of the circle. Is then tell me, is the system stable, causal?
Yes, sir. Yes, sir.
Therefore,
Yes.
system is causal for any alpha, for any value of alpha. Okay. Now, the second question is when is the system stable? Tell me.
When ROC contains unit circle.
Correct. Now, ROC should contain unit circle. But I know that the ROC of this h of n is mod z greater than alpha. So now can you use both these conditions and tell me what should be the condition on alpha so that the ROC will contain unit circle? Yes,
Sir, alpha should less than 1.
exactly. Your if alpha is less than 1, then essentially, how will your ROC look like? Your ROC will be something like this. This is your alpha, and 1 will be somewhere here. This will be, okay, maybe I should draw a different color. This is your unit circle. Okay, and this is your alpha. Let's say my real part. Let's say it's a real number, so it's alpha. Then the ROC will be something like this. You see, now the ROC is containing the unit circle. The green and the orange, the pink curves are intersecting each other. Therefore, ROC contains unit circle if mod alpha is less than 1, and otherwise it will not contain the unit circle. Therefore, system is bipostable if mod alpha is less than 1. Okay, and not stable if, in fact, equal to 1 also, no problem. Okay, not stable if mod alpha is strictly greater than 1, because in that case the ROC will not contain the unit circle, so the system will not be stable. Okay, so that is basically finishing this question. So the next question, which is basically the 8th question for the day, is an interesting question. Okay, so it has some pictures. Okay, so consider, okay, maybe I'll start on the next page. Question 8. Consider the discrete time causal system. Okay, remember I'm already saying it's a causal. Okay, it's a causal system as shown below. Okay, so basically I'm going to represent system itself. So you have input x of n, and that is going through a summation. Okay, an adder, maybe you can think of it as an adder. Then it gets split. It goes into another adder. Okay, and a part of it I call q of n. I take it and then I give it to a delay unit. And then I go here and then I bifurcate this into 2 multipliers. The value of this multiplier is k by 2, and this multiplier is k by 3. Okay, so what is the output here? It's q of n minus 1. So whenever I do z power minus 1, that means I get q of n minus 1 as the output of z power minus 1, because I'm delaying. If you recall, x of n minus 1 is the same as saying z inverse into x of z, right? So z inverse is used to denote the fact that I am delaying my signal by 1 unit. So z power minus n means I'm delaying the unit, the n naught means I'm delaying the unit by n naught times. Okay, so that is the meaning of that block with z power minus 1. And this going back to the adder and summing up. Okay, plus and plus. And this will go and again add with this block, plus, plus, and then you get the output. Okay, so basically it is some system. So basically you can think this entire thing is a system h of it. Okay. System impulse response is equal to h of n. Okay, is it clear? So basically it is some system. This is how your signals is getting operated by the system. Okay, the question is, it's a discrete time causal system. The question is, for what values of k is the system Lebow stable? Okay, see what is k? K is sitting here. K is just multiplies. That is the output of this k by 2 something but k by 2 times q of n minus 1. Here it is k by 3 times q of n minus 1. Okay, so that is basically your multiply. There are just multiplier plots. The question is, what values of k will the system be Lebow stable? Okay, so let's now, for the first step is to write down the equations, the signal flow equations that are depicted in the figure. What is Q of n? So basically you see Q of n is this. That means Q of n is the output of this adder. What are the inputs of the adder? So x of n plus k by 2 times Q of n minus 1 is equal to Q of n. Tell me if you agree. Just a minute, I'll move this here. Tell me if you have doubt. I'm saying x of Q of n equal to x of n plus k by 2 times Q of n minus 1. That is first equation. The second equation that I will write is, because why I'm saying is there are two adders here, right? So I'm just going to write the output of these two adder equations. The first adder equation is output is Q of n, which is equal to x of n plus k by 2 times Q of n minus 1. The second adder output is y of n. So the second adder output is what? Y of n equal to, what are the two inputs? This input and this input. One is Q of n, the other is k by 3 times Q of n minus 1. So Q of n plus k by 3 times Q of n minus 1. Is this okay? Can anyone confirm? Can anyone tell me if you have doubts? Or can anyone confirm if it's okay?
Yes, sir, it's okay.
Yeah. Okay. So now that's all. So this is, so we have basically the diagram has been converted into two equations. Now what we'll do? Take set transforms on both sides to both equations. Okay. So that gives you Q of z equal to x of z plus k by t into Q of n minus 1 will be z inverse of Q of z, and y of z equal to Q of z plus k by 3 times z inverse of Q of z. Okay. So now what we will do, we will rearrange both the equations. Rearranging both equations, what do you get? First equation, so basically you see Q of z appears here and appears here. Okay, bring this to the left hand side. So what do you get? You get 1 minus k by 2 times z inverse of Q of z equal to x of z. That is equation number 1. Similarly, if you see the second equation, what do you see in the second equation? Q of z is common, just group them up. Okay, what do you get? 1 plus k by 3 into z inverse. Sorry. 1 plus k by 3 z inverse the whole times Q of z equal to y of z. Equation 2. Now what I do? Just take the ratio of equation 2 and 1. That implies your y of z by x of z equal to Q of z into 1 plus k by 3 into z inverse by Q of z into 1 minus k by 2 into z inverse. Okay, Q of z will get cancelled. So what is this? This is just same equal to 1 plus k by 3 z inverse by 1 minus k by 2 into z inverse. So multiply z on numerator and denominator, it becomes z plus k by 3 by z minus k by 2. Okay, so basically we have gotten the system function of the system. Why? Because this y by z, y by x is nothing but h of z is equal to h of z. Okay, so now we have got the system function. What should we do now? Now we need to find the values of k for which the system is BIBO stable. What is the criterion for BIBO stability? The unit circle of the unit circle must be included in the ROC of the system function. Okay. Before that, can anyone tell me? First, we need to find the ROC for h of z. Now ROC for h of z. Okay. Now, if you remember, I stressed on one particular aspect when I wrote down the question. Can anyone now try to guess how will the ROC be? Remember, what is the pole of this equation? What is the poles of h of z? K by 2. K by 2, right? Because z minus k by 2 should be equal to 0. Therefore, pole should be k by 2. Therefore, your ROC must be of the form mod z greater than mod k by 2 or mod z less than mod k by 2. Do you agree? Is this correct? It should be either
Yes, sir.
exterior to the circle or
Yes.
interior to the circle. Now tell me which one of these is the ROC. That's why this is where this aspect will help. See the question again. It's a causal system.
Casual system. So greater than.
Exactly. So the ROC is this, not this. This is the only possible ROC. Okay. But since the system is causal, the ROC is mod z greater than mod k by 2. Okay. So I know that ROC is going to be mod is greater than k by 2. Now it's simple. Now, for the system to be BIBO stable, ROC should include unit circle. That is mod z equal to 1. Right? Therefore, how should your k by 2 be? Your mod k by 2 should be strictly less than 1.
Less than 1.
Okay, what does it mean? Mod k must be less than 2. Okay, so for any case such that mod k is less than 2, this system, whatever we have drawn here, will be a BIBO stable system. Okay, is there any doubt?
No, sir.
Okay, great. Okay, so next we will solve. The next question is basically, okay, this was question number 8. Now question number 9. Find the inverse Z transform of x of z equal to 2z cube minus 5z square plus z plus 3 by z minus 1 into z minus 2. And the ROC given is mod z less than 1. Okay, so it's just a simple question. So the way we will do is, yes, as the way we will basically go about it is using partial fraction method. Okay, so first for partial fraction, what is necessary is that it should be a proper rational function, but your x of z is in an improper rational function, right? Because your degree of your numerator is 3, but the degree of your denominator is 2. That means first I should make it as a proper rational function. Okay, first step, make x of z into a proper rational function. How do you do? Just do long division. Long division method. Sorry. 2z cube minus 5z square plus z plus 3. And what is this? Z square minus 3z plus 2. Okay, so you have 2z, then 2z cube minus 6z square plus 4z. Then subtract both. You get z square minus 3z plus 3. Okay, so then basically plus 1. So it is z square minus 3z plus 2. Basically now again minus, you get 1. Okay, so then what does it mean? Therefore, your x of z is basically 2z plus 1 plus 1 by the divisor, z square minus 3z plus 2. I just did a simple long division method. Okay. Basically, if you recall your dividend, this one dividend equal to your, what is this called? Quotient plus remainder into divisor. Your remainder is, I think that's the way, right? Yeah, I forgot. But this is how you basically, it is okay.
Yes, sir, clear.
Yeah. Okay, thanks. So next is basically, now this is a proper rational fraction. Okay, so now what we will do is we will consider this is nothing but, therefore this is same as saying 2z plus 1 plus 1 by z minus 1 into z minus 2. Okay, let me call this guy, this third guy, as x1 of z. Let me first compute the partial fraction. Compute the partial fractions expansion of x1 of z. Okay, so basically then what you have, you have not x1 of z by z, because in that's the trick that I told you in the beginning of the class. You can write x1 of z by z as 1 by, just divide by z on both sides. So 1 by z into z minus 1 into z minus 2, which you can write it as some number c1 by z plus c2 by z minus 1 plus c3 by z minus 2. Okay, now what is z1? All there are 3 poles equal to 0, 1 and 2, but all of them are simple poles. So this is the partial fraction expansion, where c1 is nothing but 1 by z minus 1 into z minus 2 at z equal to 0, which is nothing but half, right? That is x1 of 0 at z equal to 0. Now c2 is nothing but z minus 1 into x of z at z equal to 1, which you can show that it will come out to be minus 1. And C3 is z minus 2 into x of z at z equal to 2. You can show that this will come out to be half. Okay. Therefore, your x1 of z is nothing but half minus, x1 of z by z equal to half 1 by 2z minus 1 by z minus z1 as 1 by z minus 1 plus half of 1 by z minus 2. Now take the z again that side, which implies your x1 of z is nothing but 1 by 2 minus z by z minus 1 plus half into z by z minus 2. Okay, so now let's combine all of them. X of z, what are the x of z? You have 2 terms here. You see here, there are 2 terms, 2z plus 1 plus x1 of z. Let's write that here. So x of z equal to 2z plus 1 plus half. There was a 1 plus another half will be 3 by 2. 3 by 2 minus z by z minus 1 plus half into z by z minus 2. Okay, and what you have is mod z less than 1. You see that the question has mod z less than 1. Okay, so now using this ROC, using this principle, using this Z transform, you need to just take the inverse inverse Z transform. Okay, so now you see what the importance is. What is the meaning of mod Z less than 1? That means it represents the interior part of a circle. What does it mean? It means that your time domain signal should be a left-sided signal. That is the way you should interpret. Okay, that way you will be able to get back to your signal. So 2Z, what is the inverse Laplace transform of 2Z? It is nothing but 2 times delta of n plus 1. Okay, the inverse Laplace transform of 2Z is 2 times delta of n plus 1. For 3 by 2 is just a constant. The constant will just get multiplied with 3 by 2 into delta of n. If you remember, delta of n has a Z transform equal to 1. But constant just get multiplied. That's why 3 by 2. Now, for Z by Z minus 1, how should it be? Remember, Z mod Z less than 1 is the interior part of a circle. Therefore, you should take the left-handed signal. So it is nothing but plus u of minus n minus 1. Okay, and for you see this case, okay, half times Z into Z minus 2, you can show that again. This you're supposed to take minus half into 2 power n into u of minus n minus 1. Correct, because alpha equal to 2 here. Here I ideally should have been 1 power n, but it doesn't matter whether it is 1 power n is just 1 only. Okay, so then if you write down the combining all the equation, your x of n, this was your x of n. Okay, this is a left-sided signal. Left-sided signal because ROC is interior part of circle. Therefore, your x of n, just combining, you get 2 times delta of n plus 1 plus delta 3 by 2 times delta of n plus 1 minus 2 power n minus 1 whole into u of minus n minus 1. Okay, is there any doubt?
Sir, instead of taking x of z, why we have taken x of z by z, sir?
So basically the reason is, see here, if I take z here, then I can again right multiply z here, so it becomes z by z minus 1, for which I know the inverse transform is, these types. If I had taken directly
Okay,
x of z, I would have just had 1 by z, something like that, for which I don't know the ready-made formula for inverse Laplace z transform.
okay, sir. Okay, sir. Okay, sir.
Yeah.
Got it.
Sure.
Sir, another doubt.
Yeah.
Half is written as 2z plus 3 by 2. Why is it taken like that, sir?
That's because you see there is a 1 here already, and that one I'm adding with another half, so that becomes 3 by 2.
Okay, sir. Okay. Right, sir. Right. Thank you.
Yeah. Okay, so we have 2 more minutes. What I will do is I will solve one last question, and then we'll stop for today. Is a question 10. Okay, find the inverse Laplace transform, sorry, Z transform of x of z equal to 2 plus z power minus 2 plus 3 times z power minus 4 by z square plus 4z plus 3 when mod z is greater than 0. Okay, there is a difference between this question and the previous question. You see, in the previous question, the powers of z were positive in both numerator and denominator. But you see, for example, here you had here basically you will have z square, z power 1. Here you have z power cube, z square, z, and so on. But in this question, you have z power minus 2 negative power in numerator and positive power in denominator. What I'm going to do is I'm going to use this and apply a clever trick. Okay, so basically I can view this as solution. Okay, I can write x of z as 2 plus, okay, Okay. Maybe what I will do is 2 plus z square z power minus 2 plus 3 z power minus 4 by z into z by z square plus 4z plus 3. Okay. So this is nothing but 2z inverse plus z power minus 3 plus 3z power minus 5 into z by z square plus 4z plus 3. Now call this as x1 of z. Okay, call this as x1 of z. Now you see, now x1 of z has positive powers in both numerator and denominator. Okay, now, okay, so what we will do is first I will compute x1 of z. First I will compute the partial fraction for x1 of z. I will tell you why I am splitting this into two factors. It will become clear when after I write the partial fraction expansion of x1 of z. Okay, so basically what is x1 of z? Is equal to z by z square plus 4z plus 3. Okay, so basically this implies your x1 of z by z equal to 1 by z square plus 4z plus 3. This you can write it as some c1 times by, okay, this you can factorize it as 1 by z square plus z plus 1 into z plus 3. This I can factorize as c1 by z plus 1 plus c2 by z plus 3. Okay, so then what is c1 is nothing but um, mm, you can show 1 by z plus 3 at z equal to minus 1. That is basically equal to half. And similarly, you can show that C2 is equal to 1 by z plus 1 at z equal to 3 minus 3, which will come out to be minus half. Therefore, your x1 by z or x1 equal to half into z by z plus 1 plus minus half into z by z plus 3. Okay, again it's given in the question mod z is greater than 0. See the question? Mod z greater than 0. Now, okay, this is x1 of z. Now it will become clear what is the use of splitting this into two fractions. Okay, so what did I do? I did x of z is equal to 2z inverse plus z power minus 3 plus 3z power minus 5 into x of z, x1 of z. Now, can I write this as x of n as 2 x1 of n minus 1 plus x1 of n minus 3 plus 3 into x1 of n minus 5. Can anyone tell me if it's okay?
Yes, sir.
Yeah, this is the exact trick and then I'm applying. Therefore, taking inverse z transform IZT. I get this. So basically what it means, if it is now just sufficient to know what x1 of n is, which is precisely the inverse Laplace transform of x1 of z that I computed here. Okay, so basically all I did is I brought out all the negative powers outside and I converted them into delays in the time domain. And the delay that I'm applying to a signal, I will compute the inverse Laplace transform as shown here. Okay, so basically, therefore, what remains is to compute x1 of n. Call the above equation is equation 1. How is x1 of n computed? Just take the inverse Laplace transform of x1 of z. This equation here. Okay, so what do you get? And it's given that mod z is greater than 0, which means ROC is basically out. I mean, it's basically mod z greater than 0 is exterior part of a circle of 0 radius. Therefore, it should be a right-handed signal. Okay, therefore x1 of n is Yeah, tell me half into minus 1 power n into u of n.
U of n.
Yeah, minus half into minus 3 power n into u of n. Okay, that is just same as half into minus 1 power n minus of minus 3 power n into u of n. Call this equation 2. Now put 2 in 1. Okay, I found x1 of n, substitute in equation 1, which gives you x of n. So x of n, you can write it as 2 and 2 would cancel for the first term. So it is just minus 1 power n minus 1 minus 3 power n minus 1, the whole into u of n minus 1. That is the first term. Plus half into minus 1 power n minus 3 power n times, sorry, that should be 3, right? Minus 3. And here also minus 3 whole times u of n minus 3 plus 3 times x1 of n minus 5 plus 3 by 2 times minus 1 power n minus 5 minus 3 power n minus 5 into u of n minus 5. Okay, is it clear?
Yes, sir.
Yeah. Okay, then so yeah, you can do furthermore simplification. I don't know, but this is enough. So that basically brings me to the end of today's class. Are there any doubts?
Thank you, sir.
Yeah. Okay.
Good night, sir.
Okay.
Good night.
Yeah. So let's meet next week again.
Thank you, sir.